Hello everyone and welcome to another video of Vivek Learns. In the last video we had done some analysis about the sprint zigzag problem. So let's have a quick recap of this and then we'll move to the next video of the recursion series that we are solving. So we had analyzed this problem using both ways and we find that the optimized approach was iterating through this Euler's tree through a Euler's path. So we call this as a left call. Let's see. And we call this as the right call. And this is the pre area. And this is the post area. Sorry, this is the in area. And this is the post area. And we start iterating from here, here, here. And wherever there are print statements, we print the output. Like this is how we'll follow the Euler's tree. So let's continue this recursion series by solving another question. So in this video we'll solve the next question, which is, I think it was Tower of Hanoi. Yes, Tower of Hanoi. So let's read this question. There are three towers. Tower 1 has n desks where n is a positive number. Tower 2 and 3 are empty. So let's try to draw this first. Tower 1 has 3 desks. The desks are placed in the terms of size is that the smallest disk is on the top and the largest is on the bottom. You are required to print the instructions to move the disk from tower 1 to tower 2 using tower 3. Following the rules, move one disk at a time. Never place a smaller disk under a larger disk, and you can move only move a disk at the bottom. So let's consider an example, right? So we are given three number of disks, so we'll have to have three disks. So let's say 1, 2, 3. Say this is the weight 3, this is the weight 2, and this is the weight 1. And what the final expectation is that all these disks should be placed here. So we'll solve this using the approaches that we had solved other problems earlier, right? So we'll have some faith and then we'll have the expectation that we just mentioned, and then we'll try to go from the fate to the expectations, right? So suppose I create a function, right? Let's say I create a class first, create a function called TOH, let's say. And I take input num as the number of disk or the disk, enter number of disks, and then I call this TOH function, let's say. So this TOH function will print the number of disks, the instructions, right, to move from this disk. So we'll have three towers. So let's say in T1, let's say in T2, or we can have them as string, right? String t1, string t2, and let's say string t3. And we'll have to take the inputs of the tower, like the IDs of the tower also. Let me fix this typo, number of disks, right? So we'll have to print enter IDs of 3 tower. We'll have to enter 3 IDs. Say T1 ID, and this is T2 ID, and this is T3 ID. And the expectation that we have is that we should move them from tower 1 to tower 3. From tower 1 to from tower 1 to tower 2 using tower 3. And we should follow these instructions that we have. So let's rename this. Let's say this is the 4th tower and this is the destination tower, and we'll call this tower as the helper tower, let's say. So let's establish some faith. So the faith I have established is that if I give the input to this function as 2, and then I give something like expect the input as t1, t2, t3. Like this is t1, this is t2, and this is t3. And if I give this TOH function input as 2, t1, t2 and t3, it will automatically print the instructions to move the disk from t1 to t2. But that is not what we want, right? We want to first move to t3 and then we'll move to t2, right? Then we'll move this third disk to t3, and then we'll have again those disks move to t2, right? So how will we do it? So first what we'll do is we'll try to have this code TOH will give n minus 1 disks, right? Disk minus 1. Then we'll move from source to what is the destination? The destination will change to helper. We'll have to go to helper first and then using destination, right? So this is what we got here. So after this, what happens is we get this, this, and this. So we have 2 and 1 here. Then we have the weight third as here, right? So now what will be the next step? We'll have to move this disk here, right, to T2. So that is what we'll print. So what we do is we print move. So in the generalized form, we'll have this as the nth disk, right? So we'll move n to and from, let's say first, right? From src plus 2 plus destination. move n, oops, not the n, the disk. We have moved the disk from src to destination. Suppose this happens, then we move this. Let's say I take an eraser from here, which is this. I erase this and I move it here. So this disk is here now. So now what we'll have to do, we'll have to write the instructions to move this disk from here to here, which we have already written, but for other example, right? So we'll copy this function. So this time what it does is it will move n minus 1 disk, like disk minus 1 from destination, right? Like from destination to, like, from helper to destination, sorry, from helper to destination using source. And we need to have some base case also, right? So let's consider the base case as if disk is equals to 0, then we just have to return. So let's try to draw an Euler's diagram for this, right? So let me erase this first. Let me show how it will work. So we have 3 disks, right? And we give the input as src, destination, and helper here. So let me have this here, 3 comma src comma destination comma helper. Then we branch off this, not as much, but till this. And then what we'll have is branch off to 2 comma we swap. For the left call, we swap. What do we swap? We swap the last two, these two elements, right? We swap these two elements. We keep the src as it is, and we swap the destination and helper. So we'll have helper destination. So let's suppose we have this. And then for the right call, what we have is 2 comma. We'll swap the first and the last. So the first and the last are swapped. The destination remains as it is. The first becomes helper, destination remains as it is, and this becomes src. Then we again branch off. So what will we have here? We'll have 1 comma. We swap the last two, right? So src will remain as it is. Then what we do is we have destination comma helper. Then here again what we'll have is 1 comma src, like last two will be sub destination comma helper will remain as it is, and then we'll have src. Let me move this a bit here, and for this we'll have 1 comma. We'll have to swap the first and the second, right? No, for the left call we'll swap the second and the last one, right? So helper remains as it is, comma src comma deft. Let me have it here. 1 comma helper remain, the first remain as it is, then src comma deft gets swapped. Okay, for this call, the right call, we swap the last and the first and the last, right? Destination remains as it is, and then helper comes here. For the 0th call, which is the last call, because that is our base case. So let's try to have that as well. We'll have 0 comma src will remain as it is, and then we'll have helper comma destination. For this call, we'll have 0 comma helper, the first and the last get separate, helper destination remains as it is, and src comes here to the last. We have it shifted a bit here, and for this call what we'll have is 0 comma, for the left call we keep the first element as it is, and we swap second and third. Zero comma, we swap the last and the first for the right call, right? For this right call, we'll have something like this is the left call, so we'll have destination comma src. Let me move it a bit here. We have another right call, correct? Says 0 comma destination comma src comma helper. The one for this will be 0 comma src will remain as it is, helper and destination it's swapped. For this also says 0 comma helper will come first, then destination will remain as it is, then we'll have src, right? I don't know how I'll made a typo here. Let me erase it and have it written again. So for the left call, what we do is we swap the last two elements. And if we observe this problem, what we do is we print the instructions when we are in the middle. So let me have that code here. right? So this is the left call that we have. Let me have it highlighted. This is the left call. This is the in area, and this is the right call. Area. So what we have done is we have printed in the in area. So we'll trace this Euler's path and we'll print only when in area is present. So let's start the tracing now. So we'll start from here, over here, here. We hit the base case. Then we print this. We print here. What do we print? We print move one disk, right? From source to destination, right? Source to dest. Like this is the first. Like let's say our case from T1 to T2, right? From source to destination. Like T2 is our destination for the problem. Then we come here again. Let me trace it again. We come here, we hit the base case again. We come down here, we come to the post area, then we again come here. So what do we print in this in area? We print move to disk. I mean 2 is the weight here from SRC to helper. Okay, so what it will do, it will move the disk of size 2 from SRC. What is SRC? T1 to T2 or to T3. Helper is T3, right? So it will move the larger disk to T3. So now what we'll have to do is we again come up. We again hit the base case and then we hit this in area that we have. So we'll print the instructions, which is move one disk, meaning the disk of size 1 from destination to helper. So the destination is nothing but T3, right? And the sorry, T2 is the destination. The helper is T3, correct? So we'll move one disk from T2 to T3. So the state will be 3. The disk of size 3 will be present here. There will be no disk present in tower 2, and there will be 2 disks of size 2 and above that of size 1 present in tower 3, right? So we hit the base case. Let's continue tracing. Then we come up here again. Then what we have done is we come here to this one, and here is where we print the third case, right? Move 3 disk, like the disk of size 3 from SRC to destination. So this is what will be printed. Move 3 disk from SRC to destination. that is T1 to T2. So that is what will be printed after this. Then let's again continue tracing from here. We again come here, we again come here, we hit the base case here, which prints move disk 1 from helper to src. Helper is T3, src is T1. So this prints this instruction that we have here, right? And then we again start the tracing from here. We come here again. So what will this print? This will print move disk 2 from helper to destination. So helper is nothing but T3, right? And destination is T2. That is what will be printed. And we'll continue the tracing from here. It will come here again, hit the base case. It will come here after that. So what do we print here? We print move disk 1 from move disk 1 from src to destination. So what if the destination is? Destination is T3. So and src is T1. So what it will do is it will try to print this. src to destination, right? So destination is T2, my bad. Correct. Move disk 1 from src to destination. And then we again have hit the base case again here. Then we come down from here, and then we end the Euler's path. So precisely, if we are not wrong, these would be the instructions that will be printed. So let's try to run it. Let's first call this function. TOH will give input as disk, comma, T1 ID, T2 ID, and T3 ID. We'll have to declare this as static just to be sure. Something seems odd. What is this error? Okay, we'll input as 3. But in the problem they have taken the input as, but let's see, let's take the input as 3. Let's try to run this. But I think we'll get a problem for scanning. Let's see. It's T1, T2. Yeah, so that is one of the bugs that we have. Oh, let me have this statement to fix that. Let's see, we have 3 desks. Three disks, and then I think we'll have this spline, sorry, have 3 disks. Then we have T1, T2, T3. Yep, let's try to compare both these results. Oh, if I say copy here, or should I copy this from here? Copy it here. From T1 to T2, T2 to T3, T1 to T3, T2 to T3, T1 to T2, T3 to T1, T3 to T2, and T1 to T2. 1 to 1, 3, 1 to 1. Yep. So this is how we solved this Tower of Hanoi question. So what we did was we first established the faith that, like, this is the faith that we have established, that given 2 disks it will automatically move from src to helper. From T1 to T3 this function will automatically print those instructions, and then the only thing that we had to do was move the largest disk, which is the nth disk, from the source to destination, and then again we had to move the disk from the destination, like the helper to the destination, right? From helper to the destination. So this is how we have solved this question, and that will be all for this video. Thank you. See you guys in the next one.